Okay, we're gonna look at reviewing for our semester 1 exam. Now remember, all these problems correspond to notes that we have already taken. So you should have notes. You should have information about all these sections. So module 1, if you recall, dealt with absolute value. Remember, absolute value is the distance from 0. It typically makes numbers positive if they're negative. If they're already positive, they stay positive. So in Module 1, the first thing we did is we solved absolute value equations. So if we have an absolute value equation, say the absolute value of x equals some number, then we always split that into two equations. We made this x equal to a and x equal to negative a. So if we look at our first example here, we have the absolute value of x minus 5 equal 5. So we'll split this into two equations. X minus 5 equals 5. And x minus 5 equals negative 5. We can simply solve this by adding 5 to both sides. So x equals 10. Adding 5 to both sides here. So x would equal 0. So these would be the two solutions for this absolute value equation. So the second one, we have 3x plus 4 equals negative 8. This is actually a really easy problem because this is no solution. And let me explain why. Because it's saying the absolute value of something is equal to a negative number, this is impossible. If I refer back up to the top, the absolute value of a negative number is a positive. The absolute value of a positive number is a positive. So you can never take an absolute value and get a negative number. So B would be no solution. So that's kind of a trick question where you just have to kind of look out for that negative sign. C, we have two absolute value bars. We have x plus 5 equal 2x plus 4, both an absolute value. We'll do the same thing. So the first equation, I'll just drop the absolute value bars. And then for my other equation, I'll set it equal to negative the other expression. So we're doing the same thing. We're just taking it with the positive and with the negative. So this one, I'll just take away x, and I'll take away 4 to balance the equation. So these go away. This would leave me 1x equals 1. So 1 would be one of my solutions. Now over here, I would have to distribute this negative sign. So this would give me x plus 5 equals negative 2x minus 4. So if I solve this, I would add 2x, seems easiest. And I would subtract 5. So these go away and these go away. So this will leave me 3x equals negative 9. And I'll divide by 3, so x is negative 3. So again, absolute value equations always become two equations. So let's look at some absolute value inequalities. Now if you recall absolute value inequalities, we said the absolute value of x, or whatever, less than a number, always turned into an and compound inequality. And the absolute value of x greater than a number always turned into an or inequality. I'm going to put one other thing. If you recall, for a and inequality, you typically always get solutions that are between, and an or you get inequalities that are on the ends. And we'll see what that means. So our first one, A, says the absolute value of x plus 2 less than 5. So less than is an and. So I can really rewrite this as x plus 2 less than 5 and x plus 2 greater than negative 5. So the same thing, I just switch the signs and make it an and. So if I solve this by subtracting 2 on all these, I get x less than 3 and x greater than negative 7. So when I plot this, here's negative 7, here's 3. So I want all numbers that are both smaller than 3 and bigger than -7. So that's going to be all of these numbers, and that's why I said between. Because for these ands in the absolute value, it's always going to be these numbers between. And it's less than, not less than or equal, so these would not be included. So you put the open circle or the parentheses. So our solution in interval notation would be all points between 7 and 3. Remember, we use parentheses if it is not equal to, and if it was equal to, we'd use brackets. All right, let's look at B. Now, B is one of our OR ones because it is greater than or equal to, so we have an equal in this case. So I'll write this as y plus 2 greater than or equal to 6, or y plus 2 less than or equal to -6. So if I solve this, subtracting 2, y is going to be greater than or equal to 4, or when I subtract 2 here, y is going to be less than or equal to -8. So here's my 4 and here's my -8. So less than or equal to -8 goes this way, and greater than or equal to 4 goes this way. So you can see what I meant when I said it's the ends. It's the ends of the number line. So when I write my interval notation, there's two parts. It's -infinity to -8, bracket, because again, it's equal to, union, bracket 4 to infinity. So we're basically taking this part and then this part. So again, for these greater than inequalities, you get the ends, and for the less than, you typically get the between. Okay, so Module 2 dealt with solving the systems of equations. So when we try to solve these systems by equations by graphing, we're trying to find the intersection. So what I've done here is I went ahead and I graphed these two on Desmos. So you can see that here. And so you can see that on this, you can see their intersection is at 2, 0. So really simple. You just graph them both. You can see how I put the equations in. And then I just found their intersection. So based on our graph, we would say the intersection of these is 2 and 0. Okay, so we can also do these algebraically. So number 4 we want to solve by elimination or substitution. Either way is okay. So A, I would say this is kind of tailor-made for substitution because if you see, this equation has y by itself. So I will substitute that into the other equation. So that'll leave me with 3x plus 7 times y, but y is 5 minus x equals 19. So I can distribute. So I get 3x plus 35 minus 7x equals 19. I can combine like terms. I get negative 4x plus 35 equals 19. I'll subtract 35. So that gives me negative 4x equals negative 16. I'll divide by negative 4, so x is 4. So the first part of my answer for this is 4, comma something. But now I have to figure out what the other part is. The other part, I could just plug in the x, and you can plug it in anywhere. I'm going to plug it in right here. So y is going to be 5 minus 4. So y is going to be 1. So the ordered pair solution of this would be 4, 1. If I wanted to check it, I could just put those two equations in Desmos, make sure they do intersect at 4, 1. So graphing is a really nice way to check because we have the Desmos tool and it's so easy to graph the lines. Okay, let's look at B here. We have 4x minus y, 5x plus 2y equals 6. Now this one I'm going to do elimination because I notice here that I have the 2y. So if up here I can make a negative 2y, I could have those eliminate. So I'm going to multiply the top equation by 2. That will leave me with 8x minus 2y equals 20. And again, I multiply everything in that equation. And I'm just going to leave the second one alone. Because if I leave it alone, now these two will eliminate. 8x plus 5x is 13x equals 26. So I divide by 13, so x is 2. So 2 is the first part of my answer. And then I'll plug in to find y. I can plug into any equation I want. I'm just going to pick the second one. So that's going to be 5 times 2 plus 2y equals 6. So it's 10 plus 2y equals 6. I'll subtract 10, so 2y equals negative 4. So dividing by 2 gives me negative 2. So 2, negative 2 would be the solution. And again, you could obviously graph those and make sure that it does meet at that point. Okay, let's set up our system of equations for this word problem. So we have last year the volleyball team paid $5 for socks and $17 for shorts, spending a total of $135. The team purchased 27 items. That seems relevant. How many of each item did they purchase? Okay, so when setting this up, I'm going to call X the number of pairs of socks, because we want to know that. And Y, we also want to know the number of pairs of shorts. Now we know two key pieces of information. We know there are 27 total items and we spent $135. So we want to write two equations. The first one is based on how many items we have. So that first one says that we have X plus Y, so number of socks plus number of shorts. Well, there are only 27 items, so X plus Y must equal 27. Now, as for the money, each pair of socks was $5, so the total value of all the socks will be 5X. The shorts were each $17 a piece, so that would be 17Y, and our total valuation is $135, because it says that's how much we spent. So here are my two equations. So I can solve this by substitution, elimination, whatever you want. I'm just going to do elimination because it seems easy. So I'll just multiply this one by negative 5. So that's going to lead me to the two equations, negative 5x minus 5y equals negative 135. And 5x plus 17y equals 135. So these eliminate. This will give me 12y, and this would actually give me 0. So when I divide by 12, I get y is 0. So y was pairs of shorts, so I actually bought 0 pairs of shorts. So that's half the problem. So I really bought no shorts, so that means I bought all socks. And since there were 27 items, 27 pairs of socks. A weird way for this problem to work out, but it is possible, because if you take 135 divided by 27, it is 5, which is basically all socks. All right, our final problem here is going to be solving one of these three variable systems of equations, where we have x, y, and z. If you remember, these are the ones that take a little bit of work. So what I'll do first is I will pick any two equations, so I'll pick the first two. So that gives me x plus y minus z equals 2. 2x minus y plus z equals 4. And I'm going to eliminate, you can eliminate any variable as long as you eliminate the same variable. I'm going to add these together and try to eliminate y. So y will eliminate, but in a really ironic twist, so does z. So we get 3x equals 6, divide by 3, so now we know x equals 2. Okay, so we have one of our three variables. Now, both of those don't have to cancel out. We just got kind of lucky. Next, I'll go ahead and I'll look at these two equations, 2 and 3, and I'll try to eliminate y again. And I picked y because it looks really easy to eliminate in these two as well, because they're already opposites. Now, you'll notice z does not eliminate in this case. So this gives me 5x, these eliminate, minus z equals 9. So we have this equation. Now in a typical problem, this problem here might have an x and a z, and then you would just eliminate the two we have. But in this case, like I said, we know x is 2, so I can just substitute that into here to find z. So 5 times 2 is 10, minus z equals 9. So I'll subtract 10, so negative z equals negative 1. So z equals 1. So now we have 2 of our 3 variables, now we just have to find y. And I'll just plug it in this first equation, which says x plus y minus z equals 2. Well, x is 2, we don't know y, z is 1, and that equals 2. So, if I put this together, I get 1 plus y equals 2. I subtract 1. So y is going to equal 1. So 2, 1, and 1. We can check that up here. 2 plus 1 minus 1 is 2. That's true. 2 times 1 is 2. 2 minus 1 plus 1 is going to give me, or 2 times 2, pardon me, is 4. Minus 1 plus 1 is going to give me 4. 3 times 2 is 6. 6 plus 1 is 7. 7 minus 2 is 5. So our ordered triplet would be 2, 1, and 1. All right, hopefully this would was helpful for you to review some of our topics from earlier this semester. There will also be 2 more reviews to help us prepare for our exam.